Good afternoon. Sorry, some technical issue. Okay, so yesterday we have completed NFA to DFA. We'll continue with that. So we have done three questions, and first of all, I'll have a brief revision. Okay, every DFA is also NFA, but every NFA is not DFA. And every DFA, for every NFA, we can construct an equivalent DFA. What is DFA? If it satisfies the two conditions. What are the two conditions? At every state, for every input, it must be defined. First condition is every state must be defined for every input. And second condition, at every state, for every input, it must have single output state. So these two conditions satisfied, then only the machine has to be DFA. If it violates any of these two conditions, then it comes under NFA. And every DFA is NFA, but every NFA is not DFA. So we have done the conversion. Okay, so we have done three questions. So when we do NFA to DFA, then DFA may be having equal number of states. So in the first example, we have NFA2 and DFA is also 2 states. In the second example, we have 3 states in NFA and equivalent DFA we have 5 states. In the third example, we have 3 states in NFA, equivalent DFA has 6 states. So when you convert NFA to DFA, the DFA may be equal, may be more. So as per whatever the examples we have done, as per those examples I am giving you. Okay, so I repeat guys. So any automata, any finite automata is said to be DFA if it satisfies the two conditions. What are they? Every state must be defined for every input, first condition. Second condition, at every state for every input it must have single output state. If these two conditions satisfied, then only it is said to be DFA. And every DFA is also NFA, but every NFA is not DFA. Okay, so this is about we have done yesterday. Now, and also we have seen the basic definition of the finite automata. Okay, now based on this we'll do some questions, and today we'll do equivalence between two automatas and minimization of DFA, and then elimination of null moves if the time is there, depends on that. So these three topics I'll complete. Okay, equivalence between two automatas, minimization of DFA, compulsory these two will do, and depends on the time. If the time is there, I will go for elimination of null moves. Okay, the class is still 4:30, and tomorrow you have the class of digital electronics from 1 to 9. So digital electronics, whoever attended earlier, they will not be permitted to attend again to the class. So only the new students who have not attended for earlier digital class, they can attend. Okay, tomorrow 1 to 9 digital class, tomorrow and day after tomorrow also. Okay, 1 to 6. Okay, 1 to 6. Tomorrow is 1 to 6. Okay, tomorrow is 1 to 6, and day after tomorrow the timings you will get tomorrow. Okay, so tomorrow we have the class digital electronics 1 to 6. Okay, now we'll do some questions. Some questions, very basic questions. The given machine accepts. The given machine accepts. Look at this one. The given machine accepts. Options: A, all strings. B, epsilon only. No string, none. Look at this one. The given machine accepts. So yesterday I told you what is the acceptance. Yesterday what we have covered, what is the basic definition of the finite automata, what is its structure, what are the applications of finite automata, and how a string is said to be accepted by finite automata. Then I have gone for NFA and DFA. Okay, so look at this one, give me the answer. Okay, I didn't get any answer. The given machine accepts. So yesterday I told you, I repeat, a string is said to be accepted if it starts at initial state, and the string is completed, and when the machine stops, if it stops in a final state. Whenever the machine stops, if it stops in a final state, QF is a final state, then the string is said to be accepted. If it stops in a non-final state, not accepted. And one more condition, even though it stopped in final, if the string is not scanned completely, and even it reaches the final state, the string is not accepted. Okay, so two conditions, total three conditions. It has to start from initial state, and it must reach the final state, and the string must be scanned completely. These three conditions must be satisfied. Okay, so I repeat guys, a string is said to be accepted if it starts at initial state. Of course we have initial state, let the name of the state is Q0, and if it stops in final state, then the string is said to be accepted. Here, do we have any final state in this question? Do we have any final state? Here there is no final state. Here no final state in the given machine. When there is no final state, it cannot accept anything. When there is no final state, the machine cannot accept anything. Therefore, the machine accepts no string. Don't say none. None means when ABC options are not correct, you can go for none. So here the machine don't accept anything because no final state. That is the reason it is no string. Okay. So take this question. We'll go to next one. Your answer is no string. Next, the given machine accepts. Next question. The given machine accepts. This is the next question. The given machine accepts. The given machine accepts. The given machine accepts. No string means in the previous question, this is the answer. I'll go for previous question. The answer is empty. So here no string is accepted. So according to the option, if instead of no string, if it is given as this one, L equal to or if it is given as this one, then you can go for 5. So according to the options you have to go. Okay, so here the option is no string. So the machine don't accept anything because there is no final state. I am talking about the previous question. Now come to the present question. The present question is this one. The given machine accepts. Here we have initial state and we have final state. Okay, and initial state is final state. Initial state and final state both are same. When initial and final state both are same, it accepts minimum epsilon. I repeat, when initial and final state both are same, it accepts minimum epsilon. So go for epsilon. And moreover, it may accept some more strings. If inputs are defined. What is the inputs here? Inputs is not given. Okay, I repeat, whenever the initial and final state both are same, here initial is Q0 and final is also Q0. So whenever initial final state both are same, it accepts epsilon. And moreover, it has not defined any inputs. Even though inputs are not defined, it is a finite automata. Yesterday I told you, if initial state is there, that's enough. Initial state is there, that's enough. It is a finite automata and there are no inputs, and even though there are no inputs, initial state and final state both are same. That is the reason it accepts epsilon. And whatever the string I give, it is not defined. Suppose if I give input string A, B, B, the machine starts from Q0. Are you following? The machine starts from Q0. Q0 on A, we have not defined. Then what happens? When we don't define, the machine stops. When we don't define, the machine stops. Where it has stopped? It has stopped in Q0. Where it is Q0? Final state. Are you following? Here Q0 is the initial state and input string is ABB. The present symbol is A. Q0 on A, it is undefined. Whenever the machine is undefined, it stops. Where it stops? Q0. And what is Q0? Final state. Means accepted, not accepted. Even though it stops in final state, we say not accepted. Why? The string is not scanned completely. Yesterday I told you, 3 conditions must be satisfied. First condition, it must start from initial state and it must stop in final and it must read the string completely. Of course, it stopped in final, but string is not completed. Therefore, this string is not accepted. Okay. So, here this machine except epsilon, it cannot accept any other string. Why? Whatever the input string given, the machine stops here only without reading, without completing the string, without complete reading the string, it stops. So that is the reason it cannot accept anything. So only epsilon, except epsilon, it cannot accept anything. Only epsilon is the answer. Okay? Next question. The given machine accepts. Look at this one. The given machine accepts. The given machine accepts. I need answer. Okay. So better take the question number 3 because what you are giving, I am not unable to. This is the third question. So options as it is, don't change the options. However I have given, you just take the same options. Okay. So answer here answer is none. It is a tricky question. Answer is none. Kyom? Will it accept epsilon only? Only epsilon? No. It accepts epsilon and also 0 and also 00 and also 000, also 1, 1, and any combination of zeros and ones. So only epsilon is not correct. And will it accept all strings? Okay. I will take AA and I will give AB, I will give BA. So what about this one? Will it accept all strings? Matlab kya? All strings matlab kya? There is an improper answer. It is not complete answer. All strings. Okay, I will give AA. Will it accept? I'll give BA, will it accept? I'll give BB, will it accept? So all strings not correct. And no string means will it accept? You won't accept anything? It accepts so many, na? It accepts epsilon, 0, 1, any combination of zeros and ones. So this is also not correct. So according to the machine, according to the options, the right choice is none. What is the perfect answer then? The perfect answer is all strings over set 0, 1. All strings over set 0, 1. This is the answer. Okay? All strings over set 0, 1. Just now I have started the class. Just 5 minutes back. So if the question is given all strings over set 0, 1, then you can go for this option. Then option is A. But it is not given na. Only it given all strings. Or all strings matlab. So will it accept any combination of A and B, A, B, C? No. It accepts only combination of zeros and ones. But it is not given. So that is the reason according to the options I have taken the best choice none. If you want the right answer, you just take the none as the answer, and the perfect answer you will understand. If you write the machine accepts all strings over 0, 1, all strings over 0, 1, or you can say 0, 1 whole star. Whenever you are saying all strings over 0, 1, the meaning of this one is over 0, 1 whole star. Okay, next one. Okay, now we'll go to next question. Fourth question. The number of states of a DFA equivalent to NFA of n states is option A, always more means greater than n, always less. So these are the tricky questions. So just read the question properly and see the options properly and then answer. Always has 2 power n states and D sometimes has less number of states. Sometimes has less number of states. So I have not done any only this question. This is the previous question now. Actually this question I have given as 3 different questions. Only in this question I have modified. So 1 page is enough. So this question in 3 different ways I have given, and this is the 4th question. The number of states of a DFA equivalent to the NFA of n states is always more, always less, always has 2 power n states, sometimes has less number of states. Okay, so we have done the previous questions. So based on those questions also you can answer this question. But whenever you get giving the answer, just you think and give me the answer. Don't change the options, take these options only. Okay, sometimes more and sometimes equal. So these are the options. You please don't change the options. Madhav Mishra. So whatever the options I have given, you just take as it is and choose the best one. Okay, now look at this, guys. Yesterday we have done 3 questions. In first NFA, we have 2 and equivalent DFA also 2. Okay, next in the second NFA 3 and equivalent DFA 5. Next 3 and 6. Okay, now look at this one. Here NFA, first NFA, whatever we have done the yesterday's question. In the yesterday's question, first question, NFA has 2 states and equivalent DFA is also having 2 states. So if the first option is correct, always more is correct. Do you understand? If NFA having n states, how many states will be there in DFA? If always is correct, if NFA is having n, okay, if always n is this option is right answer, then according to this, how many states it must have? Greater than 2. But how many states we have here? Equal to 2. So it must have, it may have equal also. Example, the first question, first example, we have 2. Okay, so always more is not correct. It may be equal also. Are you following? It may be equal also. Okay, next, in the second question, we have 3 states and equivalent DFA we have 5 states and always less. If always is less is correct, then when 3 are there, it must be less than 3. When 2 are there, it must be less than 2. But here we have equal and here we greater than. So this is also not correct. Are you following? Always more is not correct. It may be equal. Always less is not correct. It may be equal, may be more. Always 2 power n. If it is correct, then according to this formula 2 power n, when NFA is having 2, so what is 2 power n? 2 square, 4 states has to be there. But with 2 is 4? No, na. So if 2 power n is correct, then according to that 2 power 3 is 8. How many states we have? 5. 2 square, we have 2. Are you following? I repeat, if 2 power n is correct, if NFA having n states, if DFA is always 2 power n, then 2 power 2, 2 square, 4 states has to be there. But how many states we have in the DFA? 2 states. If 2 power n is correct, when NFA is 3, 2 power 3 kya? 8. But how many states we have? 5. So this is also not correct. Then according to this, I have done elimination process. Always more not correct, always less not correct, always 2 power not correct. Then this is the correct answer. Then how, sir? You have given equal, okay, we agree. More, okay, that is also we agree. But we don't agree if it is less. Okay, I'll tell you guys. Listen. Actually, suppose there is a NFA with 5 states. There is an NFA with 5 states. And if I convert into DFA, I got 5. Equal is possible, na? Equal is possible, na? So we have done na 2, suppose, okay, let it be 6. I have 6 states. More is possible, na? Are you following? NFA I have taken. There are 5 states and I have converted into DFA. I got 6. Then there is a procedure, minimization of DFA. Minimization of DFA. Using the minimization of DFA, I have reduced the states 6 to 4. Are you following? I have reduced the DFA of 6 states into 4 states. Means these two are equal. These two are equal. And this NFA DFA equal. This DFA minimized DFA is equal. Then are these two equal or not? Therefore, so simple guys, NFA whatever the states, DFA can be equal. We have an example. So suppose or more also possible. So 5 states NFA, I have converted to DFA, I got 6 states. Now using the minimization concept, we have not done till now, but we will do after this. So 6 states I have reduced to 4, means this NFA and DFA equal, this DFA and minimized DFA equal, then this and this also equal. So sometimes less states also possible. You have to go, okay, suppose you don't know about the D option, but always more is not correct, na? Always less is not correct, na? Always 2 power n is also not correct, na? Because we have examples, na? So the best one is D option, okay? Got it? Now, take a note. Note. The maximum number of states, of a DFA equivalent to the maximum number of states of a DFA equivalent to NFA of n states is 2 to the power of n. The maximum number of states of a DFA equivalent to NFA of n states is 2 to the power of n. Okay, copy this one. So maximum states, okay. Maximum states of NFA, the maximum number of states of a DFA equivalent to NFA of n state is 2 power n. Okay, I'll give you one question. So you please try. So concentrate here. So if NFA is having n states, DFA may be equal, may be more, may be less, but worst case the maximum will be 2 power n. So not more than that, 2 power n. Okay. So this is so copy this one. Okay. Maximum number of states of a DFA equivalent NFA of n states is 2 power n. Okay. In this question, instead of this one, if I ask you the maximum number of states, then answer is C. If I ask you the maximum number of states of a DFA equivalent to NFA of n states, then always 2 power n. Maximum is always 2 power n. This is the answer. Okay. Now I'll give you one question. It's a tricky question. You please try. Will you try? All of you are ready? Okay, now look at this one. Now, before giving the question, I will explain the question. Then I will ask you, I'll give you the question. Okay guys, listen. Don't copy, just listen. Just listen. Suppose there are 10 states. 10 states in an NFA. If I convert this 10 states NFA into DFA, because every NFA we can convert into DFA. So how many maximum states you will get? 2 power 10 maximum. 2 power 10 maximum states you will get. Okay now? So if there is NFA with 10 states, the maximum states in DFA will be 2 power 10. Okay? Now my question is, suppose if all these 10 are non-final, then if I convert this into DFA, I will get maximum 2 power 10 states. If all these 10 are non-final state, then what about this 2 power 10? All are non-final, or all are final, or some are final, some are non-final. Are you following? So if NFA is having 10 states, if I convert this into DFA, then how many maximum states will be there? 2 power 10. 10 states NFA will have 2 power 10 maximum states. If all are non-final, then these 2 power 10 all are non-final only. Why? Because we don't have final na. Are you following? I repeat. Suppose there is a 10 states in NFA. If I convert this into DFA, 2 power 10 will be there. If all these are non-final, then all these are non-final only. Where is the final in NFA? When NFA don't have, there is no final, how can you get the final here? Therefore, all these are non-final, then 2 power 10 all are non-final. Now, look at this guys. Suppose out of these 10, some are final, some are non-final. Are you following? Some are final, some are non-final. Anyway, if there are 10 states, if I convert into DFA, I will get 2 power 10 maximum. Then when NFA is having some final, some non-final, then 2 power 10 also, some are final, some are non-final. Because here it is having final also, and non-final and also final. When you convert 2 power 10 maximum, here also 2 power 10 are, some are final, some are non-final. Okay na? Now listen guys. Suppose there are 10 states in NFA. Out of 10, 3 are the final. If 3 are the final, the remaining all are non-final. How many non-final? 7 non-final. So if I convert this NFA into DFA, how many maximum states I will get? 2 power 10. That is not my question. What is my question? Out of 10, if 3 are final, then if you convert into DFA, how many maximum final states will be there? That is my question. Okay na? So I will give you the question. Now read the question. Okay, take the question. The maximum number of final states of a DFA equivalent to, okay, I repeat, the maximum number of final states of a DFA equivalent to NFA of 10 states out of which 3 are the final states. Final states is option A 2 power 3, option B 7 into 2 power 3, 3 into 2 power 7, and D 7 into 2 power 7. Okay, if you understand the question, you can try it. This is the question. Okay, the NFA is having 10 states. NFA is having 10 states. Okay, out of 10, 3 are the final. If you convert into DFA, no doubt you will have maximum 2 power 10. 2 power 10 maximum states. That is not the question. The question is how many maximum final states. Okay, copy, try. Very good. Karam, very good. Pallavi, good. Good. Saurya, good. Okay. Kumari, good. Prakatipal, good. Try karo. It's easy. So whatever the concept required, I have given all that concept. All that concept. Listen, I'll tell you. Okay? Focus here, focus. You know, whatever the concept required to solve this question, okay? Only thing is the way you solve this that depends. Now listen guys. Now NFA having 10 states. Okay, if I convert these 10 states NFA into DFA, I will have maximum 2 power 10. Okay, now out of these 10, 3 are final, 7 are non-final. Now, okay, when we convert this 10 states NFA into DFA, we will get the 2 power 10 maximum states. But what is the question? How many maximum final states will be there in this question, in this DFA? So guys, just forget about this data. Forget about this data. Suppose I am giving a different NFA. Suppose there are 7 states in the NFA. Are you following? If there are 7 states in NFA, if I convert this into DFA, how many maximum states I will get? 2 power 7 maximum. Are you following? If N of A is having 7 states, if I convert this into DFA, I will get 2 power 7 maximum. Okay. Now, if all these 7 are non-final, then what about these 2 power 7? All are non-final, na? Why? Because there is no final. There is no final in the NFA. When you convert into DFA, so you will get all of them are non-final because there is no final here. Okay, na? Now, one more thing. In any automata, tell me, is this correct or not? In any automata, is this equation is correct or not? In any automata, is this equation correct or not? Final plus non-final is equal to total. Do you understand? In any automata, final states plus non-final states equal to total. You take NFA or DFA. So NFA or DFA will have states. What states? Final state plus non-final state. Final plus non-final will give you total states. So final plus non-final equal to total. Okay guys, listen. In the DFA, how many states we have? 2 power 10. How many states we have? 2 power 10. What are these 2 power 10? Both final plus non-final. Okay na? Just listen. In this NFA, we have 10 states. Okay. 10 states, if I convert into DFA, I will get 2 power 10. Out of this 10, we have 3 final and 7 non-final. 7 non-final. From the 7 non-final, you will get the maximum 2 power 7 non-final. Are you following? This NFA is having 10 states. Out of 10, 3 are final, 7 are non-final. From 7 non-final, if you convert into DFA, maximum 2 power 7 non-final. So in DFA, total states are how many? 2 power 10. Out of 2 power 10, how many non-final? Non-final are 2 power 7. So final plus non-final 2 power 7 implies final equal to 2 power 10 minus 2 power 7. 2 power 10, can I write 2 cube into 2 power 7? So take 2 power 7 common. So 2 cube minus 1. 2 cube is what? 8. 8 minus 1, 7. 7 into 2 power 7. This is the answer. D is the answer. So this is one way. I will tell you in a different way also. Please copy. So tomorrow you have digital electronics class from 1 to 6. So already those who have attended earlier, they will not get the access to watch again. So only the new students will get the access. Okay, 1 to 6. And day after tomorrow you might have the same class, and those timings will be given to you tomorrow. Okay, now I'll tell you a different method. I will tell you a different method. Okay, copied? Copied? Now listen guys. This is the yesterday's question we have done. This is NFA and DFA. In NFA, Q2 is the final state. Q2 is the final state. When you convert into DFA, so these are the states. In the DFA, what are the final states? Wherever Q2, because in the NFA, Q2 is the final. Wherever Q2, here, Q2. So this is the final. Wherever Q2, wherever Q2, that will be a final. This will be a final. Okay na? So NFA, whatever the in NFA, whatever the final state, so those final states wherever, so Q2 alone and Q2 and Q0, even though Q0 is non-final, but Q0 Q2 combination. Why? Because in this Q2 is there. So Q0 Q2 combination, it is a final state. Are you following? So wherever Q2 is there, all of them are final state. Okay, now come to this one. Okay, I'll give you a different method. So most probably tomorrow digital, and my class will be on from Tuesday onwards. So I will not be available tomorrow, day after tomorrow and Monday. There is no TOC class on Saturday, Sunday, Monday. My class will be continued on from Tuesday onwards, evening 6 o'clock. So I don't know about the remaining schedule. You may have simultaneously digital and TOC also, maybe I'm expecting, but tomorrow you will have the digital electronics. Okay, but my next class is on Tuesday evening 6 o'clock. Now guys, I will tell you a different method. Okay, just listen. Okay, so there are 10 states in NFA, 10 states in NFA. So I am taking those 10 states. What are they? Suppose Q1, Q1, Q2, Q3, Q4, Q5, so on, Q10, 10 states. Okay, let these three are the final. Let these three are final, and let these 7 are non-final. Are you following? These three are final, and these three are final, and these 7 are non-3 are final, and 7 are non-final. And remember, from the 7 non-final, you will get the 2 power 7 maximum non-final. 2 power 7 maximum non-final. Okay, from the three final states, you will get 2 power 3 maximum states. And what are those states? Don't say maximum final states. Here 7 non-final, 2 power 7 maximum non-final, I told you. But 3 final, I didn't say that 2 power 3 maximum final. Why? Because look at this one. Q1, Q2, Q3 are the states. And what are the 2 power 3 8 combinations? Look at this. Q1 alone, Q2 alone, Q3 alone, Q3 alone. Okay, now this is one okay, anyone. If any two, Q1, Q2, Q1, Q3 and Q2, Q3. So any two. Okay, any two. Next all three, Q1, Q2, Q3. Are you following? 1, 2, 3, 4, 5, 6, 7. 7 combination. And also 5. 8 na? 2 power 3, 8. 1, 2, 3, 4, 5, 6, 7, 8. This 8th one is not a final state, guys. This is empty. This is not a final. Empty state. Empty state means undefined. Okay, only final are these 7. These 7 are final. Therefore, I can say this one, if you have 3 final states, then maximum final state will be 2 cube minus 1. If there are n final states, then 2 power n minus 1 will be the maximum final states. If all are final. Now, so how many final states we have? 7 final. What are they? Q1, Q2, Q3, Q1, Q2, Q1, Q3, Q2, Q3, Q1, Q2, Q3. 1, 2, 3, 4, 5, 6, 7. Now guys tell me, if I club any of these 7 states with these 2 power 7 states, example Q1, Q4, मिला के क्या है? Final है non-final ना? क्योंकि Q1 final ना, then Q1, Q5 final, Q1, Q10 final. So how many these are? 7 final. And how many non-final? 2 power 7. So if I club any of these 7 with 2 power 7, then 7 into 2 power 7. 7 into 2 power 7 maximum final states will be there. Okay, so take this one. 7 into 2 power 7 is the answer. Oh, Rikati Paul. So in Kolkata, where will you be? Actually, my classes are in exactly opposite to CL the realization. Classes exactly opposite to CL the realization from morning 8:30 to evening 6:30. Then we stay in near to Ruby. Our guest house is near to Ruby. That's Tagore Park. And CL the exact opposite. There is one. Earlier it was Big Bazaar, now it is Reliance, I think. In that building, top second, the 6th floor. Regati Paul. Okay, so I have explained in two ways. So 7 into 2 power 7. We go to next one. So that's all, guys. We have done some questions. So till now we have done NFA. What is NFA? What is DFA? NFA to DFA. Okay. Now we will go for equivalence between two automatas and minimization of DFA. Phi is undefined. That is the reason we have not considered this one, mister. We have not considered this one. But here in 2 power 7, phi is there. But phi means empty, nothing. So Q1 nothing. Q1 nothing is what? Q1 means final state, na? So that is the reason 2 power 7 and also 7. 7 into 2 power 7 will be the maximum final state. Okay, next one. We will go to minimization of DFA. So minimization of DFA, we will go. So next concept, minimization of DFA. So listen, it takes some time. I will tell you slowly. It is very important, very important. Minimization of DFA. Minimization of DFA. Minimization of DFA. Minimization of DFA. Now look at this one. So what is the meaning of minimization of DFA? Reducing the number of states if possible. Reducing the number of states if possible. Show again slide. Which slide, guys? So make it fast, guys. We are going slow. This one. So 3 states final, 7 states non-final. So with 3 states, 2 power 3 maximum states. Out of 2 power 3, 7 are final. Except this 5. Okay. Except this 5. Now 2 power 7 final, non-final. 7 into 2 power 7 are final. Okay. Minimization of DFA. Minimization of DFA means reducing the number of states if possible. Suppose there is a DFA with 5 states. Listen, guys, there is a DFA with 5 states. We may reduce the DFA to 4 states or to 3 states or to 2 states or 1 states or 0 states. How 0 is possible? So what is the question here? What is the concept here? Minimize, but don't vanish. So completely don't delete. So 0 states is not never. So we may reduce to 4, we may reduce to 3, we may reduce to 2, we may reduce to 1. We may reduce to 1, but not 0. Okay, or itself might be the minimized. Itself might be the minimized. So we cannot reduce every DFA because already if it is minimized one, so how can we reduce? Okay, if we reduce, how to reduce? That is the question here. Okay, so simultaneously I will give you the procedure and example. Okay, with one example I will explain the procedure. Okay, take first of all minimization of DFA. Take the notes. Minimization of DFA. It is the process of It is the process of reducing the number of states. It is the process of reducing the number of states if possible. It is the process of reducing the number of states if possible, comma. I repeat, it is the process of reducing the number of states if possible, comma, without affecting the function of the machine. Okay, so take this question. Simultaneously I will explain. Present state, next state, next state, 0 and 1. So guys, copy this. Q0, Q1, Q2. This is a little bit lengthy, but I'll make it easy very clearly. Q4, Q5, Q6, Q7 and Q8. Okay, and let Q0 is the initial and Q2 is the final. So present state, next state, copy this. Q0, Q1, Q2, Q4, Q2, Q5, Q8, Q1, Q4, Q7, Q5. I'll go for Q6 and Q2. Q6 is Q4, Q6, Q4, Q6, Q7, Q2, Q0, Q3, Q1. So guys, just copy this one. I will go for procedure. Q0, Q4, Q1, Q7, Q2, Q4, Q2, Q0. Okay. Copied. So it is little bit lengthy procedure. I'll make it very clearly. You please look at this here. Okay, minimization of DFA. Step 1. What is this? Step 1. Step 1. Okay, shall I go? Okay guys, listen. Step 1. Delete unreachable states. Delete unreachable states. Delete unreachable states. Delete unreachable states means whatever the states you cannot reach from the initial, you delete all of them. Are you following? Delete unreachable states from, that means from initial, whatever the states you cannot reach, delete all of them. That is the first step. So here what are the states? What are the states we have? We have Q0, Q1, Q2, Q3. How many states we have? How many states? 9 states. 9 states. From Q0 to Q8, Q0 to Q8, 9 states. Out of these, we have whatever the states you cannot go from initial, means whatever the states there is no path to reach them, delete them. That is a this delete unreachable states. Okay guys, listen. Q0, it has to be there. So step 1, it has to be there because it is initial. If you delete initial, there is no meaning. So Q0 on 1, I can go to Q1. Yes or no? Q0 on 1, we can reach Q1. We can reach Q1. So Q1 is reachable. Q1 on 0. So I am writing Q1 is reachable. Are you following? Q0 on 1, you can go to Q1. From Q1, in Q1 on 0, you can go to Q2. So from initial, there is a path to Q2. So Q2 is also reachable. Okay. Then okay. Now from Q2, Q1 on 1, you can reach Q4. Are you following? Q1 on 1, you can see Q1 on 1, you can reach Q4. Q4 is also reachable. And Q2 on 1, you can go to Q5. Q2 on 1, you can go to Q5. Q5 is also reachable. Q5 is also reachable. Okay. Now Q6, how can you reach Q6? Q6 on 0. Q6 on 0. Sorry, Q5 on 0. Q5 on 0. Q5 on 0, you can go to Q6. Are you following? So what are the states you can reach? From Q0 on 1, I can go to Q1. Q1 on 0, Q2. So from here, there is a path. Q2 on 1, Q5. So from initial, there is a path to Q5. And Q1 on 1, Q4. So from initial, there is a path to Q4. And Q5 on 0, Q6. So there is a path from initial to Q6. So Q6 also reachable. Okay. Now Q7. How can you reach Q7? Q4 on 1. Q4 on 1. You can see Q4 on 1. So Q7 is also reachable. Now Q3. How can I reach Q3? Q3 or Q8. So look at this. In Q3, are you following? In Q3, I write here Q3 on applying 0, you can reach to Q8. Q3 on 0, you can reach Q8. Q3 on 1 you can reach to Q1. Q3 on 1 you can reach to Q1. Now Q8 on 0 you can reach to Q3. And Q8 on 1 you can reach to Q1. Hello, this one. Now tell me guys, from initial I can reach Q1, I can reach Q2, I can reach Q5, I can reach Q5, 6, I can reach Q4, I can reach Q7. But how can you reach Q3 and Q8? How can you reach Q3 and Q8? Are you following? How can you reach Q3 and Q8? Is there any path from Q0 to Q3 and Q8? So from Q0 there is no path to reach Q3 and Q8. So Q3 and Q8 are unreachable. Q3 and Q8 are unreachable. Nikhil Verma, sir, your teaching is amazing, but please give us more time to write. Thank you. Okay, Nikhil Verma, sorry, actually, I'm feeling that I'm going slow. That is the reason I may not giving that much time to copy, and extremely sorry. I'll give you. So please tell me. Okay, now onwards I'll give you more time, because it is very big subject, and so that is the reason I have some limited time. Okay, anyway, so next time onwards I'll give you definitely more time. Okay, you just copy this one. So initial step is what? Delete unreachable states. जो भी स्टेट्स आप नहीं पहुंच सकता है उसको हटा दो. दैट्स इट. ओके, सो Q3 को Q8 को हम नहीं पहुंचेगा. सो Q3 Q8 को डिलीट करो. सो Q3 Q8 को डिलीट करने के बाद ये स्टेट्स हम पहुंच सकता है Q0 से. दीज आर द स्टेट्स रीचेबल. सो हम Q3 Q8 को नहीं पहुंच सकते ना. सो Q3 को डिलीट करो, Q8 को भी डिलीट करो. ओके ना. सो दिस इज द रिजल्ट ऑफ फर्स्ट स्टेप. S1, this one, and you can copy this one also. Here these are unreachable states. This is unreachable path. This is Q3 and Q8 is unreachable path. So just copy this, guys. Sorry, Nikhil Verma, and I'll go slow. I'll give you the time. I think you are asking for the time to copy. Okay, done. So delete unreachable states means from initial whatever the states you cannot reach, you delete them. Simple. Delete unreachable states. So copy S1. S1 result is this one. So here I am checking what are the states that can be reached. I am checking. I am not writing the complete diagram. I am not completely writing the diagram. Subhi Goyal. I am checking what are the states you can reach. From Q0 you can reach Q1. From Q0 you can reach Q2. There is a path to Q5. There is a path to Q6. There is a path to Q4. There is a path to Q7. That's it. Okay. Next. Next one. Step 2. Step 2. It is easy, guys. Step 2. Separate final and non-final. Separate final and non-final states. Final and non-final states. It is very easy steps. Separate final and non-final states. So by looking at the table, you can find what are the final states, what are the non-final states. What are the final states here? Q2 is the final. Q2 is the final. Okay. And what are the non-final? Q0, Q1, Q4, Q5. There is no Q3, na? And Q6, Q7. There is no Q8. So these are the non-final. Q2 is the final. Separate final and non-final states. Copy this one. Okay. Now, step 2. Sorry, step 3. Step 3. Separate those states. Separate those states. Separate those states. Separate those states that are directly going to the final state. That are directly going to the final state. Directly going to the final state. Going to the final state. Separate those states that are directly going to the final state. Copy this one, I will explain. Separate those states that are directly going to the final state. Okay, copied? Now look at this one. So whatever the states that are directly going, now look at this one. From Q0 on input 0, you can go to Q0. On input 1, you can go to Q1. Okay? But you cannot go directly with one input symbol. You cannot go directly to Q2 final state. What is the final state? Q2 is the final state. From Q0 you cannot go directly within one step. Okay? So Q0 is not. But in Q1 on applying 0, look at this one. In Q1 on applying 0, you can go to directly Q2. So here guys, so whatever the states like this, they are directly going. So Q1 can directly go. And listen here. Q2 already separate final state. If you say Q5, look at this one, Q5. In Q5 on input 1, it can go directly to Q2. Okay, Q1 on 0, it can go directly to Q2. And Q7 on 0, it can go directly. So Q1 can directly go to final state. Q5 can directly go to final state, Q7 can directly go to final. So except these three, no other state is can go directly. Therefore, what is the result of this one? Step 3. Step 3. Already we have separated Q2. We have separated Q2. Okay. Now from Q0, Q1, Q4, Q5, Q6, Q7, Q0 cannot go directly. Q4 cannot go directly. Q6 cannot go directly. Whereas Q1, Q5, Q7 can go directly. I can, okay. Q1 on 0, Q5 on 1, Q7 on 0. It can go directly. Whereas Q0, no. Q4, no. Q6, no. So Q0, Q4, Q6 are not directly going. Just copy this one. Copy. Okay, next one. Next, step 4. This is main point. This is main point. Step 4, main point. In each set means this is one set, this is another set, this is another. In each set, for each pair of states, check whether they are zero equivalent and also one equivalent or not. Zero equivalent and one equivalent or not. So copy this one. I will explain this point. Right white link diagram. This is not required, boss. This is not required. Just wherever Q1 on 0, it is going to final. Q5 on 1, it is going to final. Q7 on 0, going to final. Everything I am giving you explained clearly, na? Okay. So this diagram is not just for example I have given. Q0 on 0, it is going to Q0. Q0 on 1, it is going to Q1, but it is not directly going. Whereas Q1 on 0 directly going to Q2. Q1 on 0 directly going to Q2. So Q1 go to final state directly. So those states are directly going. So you write in one state, one set, those are not directly going in another set. Okay, those are going directly. So Q1 on 0, Q2, what is final? Q2 is final. So wherever final in Q1, in Q5, in Q7, you separate them. Okay, and Q0 में Q final नहीं है, Q4 में भी final नहीं है. Q6 में भी फाइनल नहीं है. सो Q0, Q4, Q6 को सेपरेट करो, Q1, Q5, Q7 को सेपरेट करो. Okay. Chalo. Now, this is the main step. In each set means what are the sets here? Here. In each set for each pair of states, check whether they are 0 equivalent and also 1 equivalent or not. Means those in the same set. Okay. Now listen. Q2 already it is single. You how can what you further you can separate. Q2 is single na? Those are multiple states in one set. You have to check. Already Q2 is single. You cannot separate them further. Now Q0, Q4, Q6 are in the same set. Q0, Q4, Q6 are in the same set. So what I do? I will check Q0, Q4, Q6. Q0, Q4, Q6. Those are in the same set. Q0, Q4, Q6 in the same set. So Q0, Q4 for 0 equivalent you check. If they are 0 equivalent, I am writing here Q0, Q4, Q0 and Q4 for input 0 you check. If input 0 they are equivalent, if they are equivalent then check for input 1. If they are 1 equivalent also then we keep in Q0 and Q4 in the same set. If they are not 0 equivalent or if they are not 1 equivalent, we separate Q0 and Q4. Okay, what is 0 equivalent, 1 equivalent? I will tell you, just wait. So Q0, Q4, Q6 are in the same set. So pairwise Q0, Q4 and Q0, Q6 and Q4, Q6. So pairwise you check whether they are 0 equivalent and also 1 equivalent or not. Q0, Q4 check karo, Q4, Q6 check karo and Q0, Q6 check karo. Okay. So if there are 0 equivalent and 1 equivalent, we keep in the same set. Similarly, Q1, Q5 check karo, Q1, Q5 and Q5, Q7 and also Q1, Q7. Those are in the same set. Pairwise you check whether they are 0 equivalent or 1 equivalent or not. I am checking Q0 and Q4. How to check Q0, Q4? Are 0 equivalent or not? 0 equivalent or not? You please concentrate here. I am checking Q0 and Q4. I am checking Q0 and Q4. Okay, just wait. S4. S4. Q2 already single, so we cannot separate further. I am checking Q0 and Q4. Q0 and Q4. Guys, this is. So I will reduce this one. Just look at this one. Okay. I will reduce this one. Now I am checking Q0 and Q4. Q0 and Q4. Here I write. Q0 and Q4 I am checking. 0 equivalent or 1 equivalent. Okay, 0 equivalent and also 1 equivalent or not. Okay, I am checking Q0 and Q4. Just look at this one. Now Q0 on input 0. Q0 on input 0. Where you are going? Are you following? I am checking Q0 and Q4 for 0 equivalent. Whether they are 0 equivalent or not. Okay, Q0 on 0. Q0. I repeat. Q0 on input 0. Q0. So we are writing S4. When you are writing S4, check the S3. Look at the S3. Look at the S3. So Q0 on 0. Q0. Where is Q0? Here. Q0 is here. Just identify. Just identify wherever Q0. Okay. Now Q4. Q4 on 0. We are checking Q0 and Q4 for input 0. Q0 on 0. Q0. Q4 on 0. Q4 on 0. Q4. Q4. Where is Q4? Here. Are you following? We are checking Q0 and Q4 for input 0. Q0 on 0. Q0. Q4 on 0. Q4. So outputs are Q0 and Q4. Q0 here. Q4 here. Now tell me the outputs of Q0 and Q4 for input 0. What are here? Q0 and Q4. Are you following? For Q0 and Q4 at the input 0, what are the outputs? Outputs are Q0 and Q4. Okay? The outputs of Q0 and Q4 for input 0 are Q0 and Q4. And Q0 and Q4 the outputs are in the same set or in the different sets? Are you following? The one output is Q naught, the other output is Q4. These two outputs in the same set or in the different set? In the same set. These Q naught and Q4 are in the same set. If the outputs are in the same set, we say they are zero equivalent. So they are zero equivalent. If they are zero equivalent, then check for the one also. If for input 1 also, the outputs of Q0 and Q4 in the same set, which set? Any set. It doesn't mean that, sir, for 0 outputs are here, for 1 also output must be in the same set. No. Q0 and Q4 for input 1, you will have some output. Those two outputs must be in the same set. The both outputs of Q0 and Q4 for input 1, they may be here, they may be here, but both the outputs must be in the same set. If in the same set, we say they are one equivalent. Okay. Now we are checking for Q0 and Q4 for input 1. Look at this one, Q0, Q4 for input 1, Q0 on 1, Q1. I repeat, Q0 and Q4, Q0 on 1, Q1. Where is Q1? Here. Q1 here. Okay. Now Q4 on 1, Q4 on 1, Q7. Where is Q7? Q7 is here. So the outputs of Q0 and Q4 for input 1. The outputs of Q0 and Q4 for input 1, Q1 and Q7. Q1, Q7 in the same set or in different sets? In the same set. If they are in the same set, then we say one equivalent and also one equivalent. Okay. So when they are zero equivalent and one equivalent, you cannot separate Q0 and Q4. So Q0 and Q4 we write in the same set. Just copy guys. Okay. Now, so guys, listen. So Q0 and Q4 in the same set. We have checked that both are zero equivalent and also one equivalent. Now, actually I told you have to check Q0 and Q4, Q0 and Q6, Q4 and Q6. Those are in the same set. Pair wise. Q0 Q4 check करो, already check किया था. Q0 Q6 check करो, okay, and Q4 Q6 को भी check करो. लेकिन Q0 and Q4 already equal है ना, so Q6 को एक ही state से check करो. मतलब Q0 Q4 already check किया था, दोनों equal है. Then Q0 and Q6 and Q4 Q6 instead of दोनों check करने के means instead of checking both of them, you just check either Q0 Q6. Okay, Q0 Q6 or Q4 Q6 किसी को भी check कर सकते हैं. So Q6 just like that Q0 and Q4 are belongs to one family. Q0 and Q4 belongs to one family. I am checking Q6 is belongs to this family or not. When you are checking the Q6 whether it belongs to this family or not, you just check with any one DNA like that. You need not to check with everyone. So like that Q0 and Q4 already equal. So check करो Q6 either Q0 के साथ or Q4 के साथ. So I am checking Q0 and Q6. Q0 and Q6. Okay na? Now listen guys. Q0 and Q6 I am checking. Now whenever you are checking, you have to check for input 0. Q0 on input 0. Q0. Q0 on input 0. The output is Q0. Now Q6. Q6 on input 0. Q6 on input 0. Q4. Yes guys. Q0 and Q6. Q0 and Q6. The outputs are Q0 and Q4. Q0 and Q4 are in the same set. Therefore, Q0 and Q6 are 0 equivalent. 0 equivalent. Then if they are 0 equivalent, check for 1 also. For 1 input also, if they are equivalent, then we write Q0, Q4, Q6 in the same set. For 0 they are equivalent. For 1 also equal, then only we write in the same set. Suppose 0 equivalent but not 1 equivalent, then we separate Q6 from this set. Okay, I am checking Q0 and Q6 for input 1, Q0 and Q6 for input 1, Q0 on 1, Q0 on 1, Q1. Where is Q1? Here. Q1 is here. Q6, Q6 on 1, Q6 on 1, Q6. Where is Q6? Q6 here. Hello, are you following? Okay, I'll use a different color. You can check this one. See, I repeat. Q0 on 1, Q1, Q0 on 1, Q1, Q6. Q6 on 1, Q6, Q6 is here. So the outputs of Q0 and Q6 for input 1 output is in this set, other output is in this set. So the outputs are not in the same set. The outputs of Q0 and Q6 for input 1 are not in the same set. Then you have to separate. Are you following? So they are 0 equivalent but not 1 equivalent. Why not 1 equivalent? For input 1, okay, for Q0, one output is here. For input 1 for Q6, the other output is here. So one is here, or the other one is a different place. So you cannot keep the Q1, Q6 in the same set, because Q0 and Q6 are 0 equivalent but not 1 equivalent. If they are not 1 equivalent, we separate Q6 from this set. Okay guys, just copy this one. Copy. Okay, now so we have done for this first set. I am going to the second set. I am going to the third set. Q1, Q5, Q7. Have you all copied? Please, I am giving the enough time, but you also please cooperate. Please make it, copy this fast. Okay na? Okay. Look at this, Q1 and Q5. Q1 and Q5. I am checking Q1 and Q5. I am checking Q1 and Q5. Why? Q1 and Q5 are in the same set. Those are in the same set. You have to check. Q1 and Q5 you have to check. Q1 and Q7 you have to check. And Q5 and Q7 also you have to check. Okay. Now I am checking Q1 and Q5. Q1 and Q5. Look at this one. Q1 on 0. Q1 on 0. Q1 on 0. Q1 on 0. Q2 is here. Q2 is here. Then I am checking Q1 and Q5. Q5 on 0. Q5 on 0. Q6 is here. Are you following? Q1 and Q5. We are checking for input 0. Q1 on 0. Q2 is in this set. Q6 on 0. Q4. Okay, one second. Sorry, Q5. Q1, Q5 na? Q1, Q5. Q1 on 0. Q2 here. Now Q5 on 0. Q5 on 0. Q6 is here. So one is here, the other one is here. So the outputs are not in the same set. So therefore Q1 and Q5 are not 0 equivalent. When they are not 0 equivalent, you need not to check for input 1. If they are 0 equivalent, then only we will check for input 1. If they are not 0 equivalent, initially we separate here. You need not to check for 1. So I am separating Q1 and Q5. I have separated Q1 and Q5. Why? Because Q1 on 0, Q1 on 0, Q2, Q5 on 0, Q6. One is here, the other one is here. So not equivalent, not 0 equivalent. Now guys, so Q1 and Q5 not equal, we have separated. Now check Q1 and Q7. Check Q1 and Q7. Suppose Q1 and Q7 also not equal. Example. Then don't write Q1 separately, Q5 separately, Q7 separately. Suppose Q1, Q7 also not equal, don't write separately Q1, Q5, Q7. If Q1, Q7 also not equal, then check Q5, Q7. Check Q5, Q7. They both may be equal. Na? If they are also not equal, then you separate Q1, Q5, Q7. So I am checking for Q1 and Q7. Q1 and Q7. Just copy this, guys. Make it fast. Already I told you na, Q0 and Q4 are equal. When Q0 and Q4 equal, we are checking Q6 with any one only. So I have given you one example. So one family is there. The outside member, one person, you are checking that person belongs to this family or not. You need not to check everyone's DNA with that person. So that person DNA, you check any one of this family member. So like this, Q0 and Q4 already equal. So you check Q6 with Q0 or Q6 with Q4. Clearly I told you this point. Sudeshna, Rakshit. So Q0 and Q4 already equal. You check Q6 or Q0. Otherwise you check Q0, Q6. Otherwise Q4, Q6. Anyone. Okay. So Q1, Q5 are not equal. I have separated. Now I will check Q1 and Q5. I will check Q1 and Q5 already done. Q1 and Q5 are separated. Now I will check Q1 and Q7. Q1 and Q7. Shall I go? Q1 and Q7. Now check this. Look at this. Q1 and Q7 I am checking. Q1 and Q7. Q1 and Q7. Q1 on 0. Q1 on 0. I am checking Q1 and Q7, guys. This and this I am checking. Q1 and Q7. Q1 on 0. Q2 is here. Now Q7 on 0. Q7 on 0. Q2. It is also in the same. Q1 on 0, Q2, Q7 on 0, also Q2. So Q1 and Q7 are 0 equivalent. If they are 0 equivalent, check for input 1. Okay, I am checking for input 1. So Q1 on 1, Q4 is here. Q7 on 1, Q7 on 1, Q0 is here. So Q1 and Q7 for input 1 is Q4, other one is Q0. Both the outputs of input 1 for Q1 and Q7. I repeat, Q1 and Q7 for input 1, both are Q0 and Q4 in the same set. Therefore, Q1 and Q7 are 0 equivalent and also 1 equivalent. So we cannot separate Q1 and Q7 because they are 0 equivalent and also 1 equivalent. So when Q1 and Q7 are 0 equivalent, you need not to check Q5 and Q7. Okay, so copy this, guys. Okay, now whatever we have done in step 4, the same procedure we will repeat in step 5, step 6, step 7, step 8 until you get, okay, until you can separate. Until you can separate, you just continue. Okay, now listen, I am deleting this one. Okay, done. Q1 and Q5 are not 0 equivalent. That is the reason Q1, Q5 are separated. Q1, Q7 0 equivalent and also 1 equivalent. That is the reason I wrote all of them in the same set. Okay. So Q1 and Q7 in the same set. Q5 is separate. Now guys, listen. I am checking S5. So whenever you are writing S5. So check S4. Q2 is single. Now I am checking Q0 and Q4. I am checking Q0 and Q4. So Q0 on 0. Q0 here. Q0 on 0. So and Q4 on 0. So Q0 and Q4 are 0 equivalent. Q0 and Q4 are 0 equivalent. Q0 on 0, Q0, Q4 on 0, Q4. Q0 here, Q4 here, 0 equivalent. Now check for 1. Q0 on 1, Q1, Q0 on 1, Q1 is here, Q4 on 1, Q4 on 1, Q7. Okay, I repeat, Q0, Q0 on 1, Q1 is here. Q4 on 1, Q7 here. So the outputs both are in the same set for input 1. The outputs for input 0 both are in the same set. Therefore, Q0 and Q4 are 0 equivalent and also 1 equivalent. So you cannot separate Q0 and Q4. Here Q0 and Q4 are 0 equivalent and also 1 equivalent. So that is the reason I cannot separate Q0 and Q4. And look at this one. Q6 is single. So you cannot separate further. Q2 is single. You cannot separate further. Okay. Just copy this, guys. Okay, next I am checking for Q6 already single na, so I wrote I am checking Q1 and Q7. I am checking Q1 and Q7. Look at this, Q1 and Q7, Q1 and Q7. Okay, so this Q1 and Q7, whenever you are writing S5, you check S4. When you are writing S6, you check S5. Okay, I am checking this Q1 and Q7. Q1 on 0, Q1 on 0, Q2 is here, Q2 is here, Q7, are you following? Q1 and Q7 we are checking, Q1 on 0, Q7 on 0, Q2. So Q7, Q1 and Q7 both are 0 equivalent. Are you following? Q1 on 0, Q7 on 0, Q2 both are in the same set. Therefore Q1 and Q7 are 0 equivalent, and I will check for 1. For 1 also equal, then only I keep. Otherwise I will separate Q1, Q7. Now Q1 on 1, Q1 on 1, Q4, Q1 on 1, Q4. Now Q7 on 1, Q0, Q7 on 1, Q0. So Q0 and Q4 in the same set. Therefore Q1 and Q7 are 0 equivalent and also 1 equivalent. So you cannot separate Q1 and Q7. And Q5 is a single state. Now guys, look at this one. We have done S5. If you look at this S4 and S5, Q2, Q2, Q0, Q4, Q6, Q1, Q7, Q5. So S4 and S5 are equal. Whenever you get same, you just stop. Even you consider S6, S7, you will get the same only. You cannot separate further. Now, therefore, how many states we have? Here, this is single 1, combination 2, single 3, combination 4, then 5. So 1, 2, 3, 4, 5 states. Earlier we have 9 states. 9 states we reduced to 5 states. When we reduce the 5 states, we reduce the number of states, we must redefine the automata. Now I will go for the redefinition. So copy this one. We have 5 states. Copy. Yes, S4 only minimized. S4 equal to S5. Okay, copied. Make it fast. So S4, S5 are equal. Then whenever equal, we stop. Now guys, I will go for the reconstruction of the machine. I will go for the reconstruction of the machine. So Q0, Q4. Here Q0 is the initial state. Q0 is the initial state. Okay. Here we got Q0 and Q4 combination. Q0 and Q4 combination. Therefore, I will take Q0 and Q4. Q0, Q4 combination we got. Q0, Q4 combination we got. Q0, Q4 will be the initial state. Why Q0, Q4 will be the initial state? Q0 is initial in the given automata. Q0 is initial in the given automata. And what is the combination we got? We got the Q0, Q4. So Q0, Q4 will be the initial. Okay. Now look at this one. We are reconstructing. Q0 on 0, Q0. Q4 on 0. Here these two are Q0, Q4 na? Q0 on 0, Q0. Q4 on 0, Q4. What is this combination? This combination Q0 and Q4 combination. Q0, Q4. Okay. That means in this state, if 0 comes, be in the same state. That is the meaning. Next, Q0 on 1, Q1. Q4 on 1, Q7. One is Q1, the other one is Q7. So what is the combination? Q1, Q7. Yes, we got the same combination. Q1, Q7. Therefore, take Q1, Q7 here. Q1, Q7. So take it. So on 1. Okay, done. Okay, now Q1, Q7. Q1, Q7. Q1 on 0, Q2. Q7 on 0, Q2. Q2, Q2, combination is Q2 and Q2 is a single state. You can see Q2 is a single state. So Q1, Q7 on 0, Q7, Q1, Q7 on 0, Q2 and Q2 is a final state. Okay. So I repeat, Q1 on 0, Q2, Q7 on 0, Q2. So Q2 is a final state. Okay. Now Q1 on 1, Q4, Q7 on 1, Q0. What is the combination? Q0, Q4. So Q0 on 1. So Q1, Q7 on 1, we will come back. So Q1 on 1, Q4, Q7 on 1, Q0, Q4, Q0 or Q0, Q4. Both same na? So Q0, Q4. Done. Now come to Q2. Q2 on 0, Q2 means itself, Q2 on 0, Q2 on 0, Q2, Q2 on 1, Q5, Q2 on 1, Q5, Q5 is a single state, okay, Q2 on 1, Q5, okay. Now Q5 on 0, Q6, take Q6, I repeat guys, Q5 on 0, Q6, Q5 on 0, Q6, okay. Next Q5 on 1, Q2, Q5 on 1, Q2, this one. Next Q6 on 0, Q4 is here, Q6 on 0, Q4, okay. Q6 on 1, Q6 means itself. So this is the minimized DFA. So we have 1, 2, 3, 4, 5 states. In the examination, they may not give the names like this. They give the completely different name. P, Q, R, S, T or A, B, C, D, E. Or even they don't give the names also. Only blank states without giving the without names. They will give the diagram. So structure is important. Okay. Copy this guys. So this is about minimization of DFA. So we'll continue on Tuesday evening 6 o'clock we will meet again, and tomorrow you have digital electronics class 1 to 6 or okay, I think 1 to 6. So the old students who have already attended, they don't get the access. Okay, only new students will get the access. Means we have not joined for the previous digital class. Okay guys. Okay, just revise these notes. Just believe me, I will give you each and every point without leaving a single point, and workbook solution also will give you video solutions. So the only thing is you just do the revision. So by that next time I'll come, we will continue. I'll give you 1 or 2 more questions, and then we'll continue the other concept. Okay guys, thank you so much. Thank you.